Okay, so in this video I'm going to be going over the Advanced Dynamics Test Part 2. This was a relatively straightforward test covering pulley problems, two-object problems, and inclined plane problems. Okay, so let's start with question number 1. Okay, so question number 1, no matter what version you had, was a pulley problem. And in this case, we have a pretty simple pulley problem. So mass 1 is on a frictionless surface, and then mass 2 is just kind of hanging. With any type of pulley problem, you want to establish a coordinate system. In other words, you want to establish which way is positive and which way is negative. And typically what you do is whichever way the system is accelerating, you make that direction the positive direction. Now in this case, because mass 2 is free to fall, it's going to fall down and pull on mass 1. And so really the only possible way the system can accelerate is clockwise. And so we're going to make that positive. And so if we think of the FBDs in this situation, we have FG2, we have tension, and I'm going to make this a negative force, and this one is going to be a positive force. FG2 is positive because it's going in the clockwise direction, and FT is negative because it's going in the opposite direction. Now, this is one string just hanging over a pulley, and so it's the exact same tension that's acting on mass 1. And so the FBD for mass 1 would have FG1, FN1, and then we would have FT. And this FT would be the same as that FT, but this one would be positive because this would be considered a clockwise force. Okay, and so if you write out your Newton's second law equations, we have for mass 1, we have F net x equals m1 ax. We know the system is accelerating. We know m1 is 8. I don't know what the acceleration is. I write down the sum of the forces in the x direction because there's no friction. All I have is Ft. And then I do the same thing for mass 2, only this time it's only accelerating in the y direction. Now, because the system, because the two objects are connected by a rope, they have to have the same acceleration. And so even though I'm going to call this one a y because its mass 2 is accelerating in the y direction, and this is a x because mass 1 is accelerating in the x direction, they're the same acceleration. And so when I plug in the mass here in a second, I can combine those like terms. So this is 9.8 times ay. I write down the sum of the forces, and I write down Fg2 minus Ft. Okay, and notice that this Ft is negative and this Ft is positive, and it has to be that like that so that you get the correct answer. Okay, so Fg2 would be m2 times g. That would just be 9.8 times 10. Notice I leave that as a positive 98 newtons because I made clockwise my positive direction. And so I end up with a system of equations. I have Ft equals 8ax. I have 98 minus Ft equals 9.8 ay. I have a system of equations that I can solve using elimination, and so I just add the two equations together. Those two cancel, and I get 98 equals 9.8 plus 8 is 17.8 times the acceleration. And then I just go to my calculator, and I do 98 divided by 17.8 equals 5.5 meters per second squared. Okay, and so that is the amount of work that you had to show for A. Okay, so that's 3 points finding the acceleration, and then once you find the acceleration, to find the tension, you just plug that back into one of the other two equations. And so in this case, the easiest way to do that is to plug into this equation, and then you can immediately find the tension just by multiplying that mass times the acceleration. Okay, and so in this case, I do 8 times 5.5, which is 44 newtons, and I'm done. Okay, so that is question number 1. Pause there if you need to look at that some more. Okay, moving on. Question number 2. Okay, so question 2 is a basic inclined plane problem. We have an inclined plane. Here we have a box with a mass of 31 kilograms, so here's my box, and it's on an incline that makes a 30-degree angle with the horizontal. The first question asks us to draw an FBD. It also says that the box is pushed down the incline. Okay, so we have the force of gravity going straight down, the normal force perpendicular to the surface, there's Fn. If it's being pushed straight down, we have Fa, the applied force parallel to the incline, and then FFk working in the opposite direction of motion. Okay, so 1 point for the free body diagram. Okay, like any second law problem, you move on to your second law equations. So I have F net x equals max and F net y equals may. On an inclined plane problem, the object never ever ever accelerates in the y direction because it is not moving in the y direction. And so this is 0. We have two forces in the y direction. Okay, that is Fn and Fgy. And so for B, we're asked to find the normal force, which means I need to know what Fgy is. And Fgy for an incline, because we use that rotated coordinate system, is Fg cosine theta. Okay, and so here that would be 31 times -10 times cosine 30 degrees. Okay, and so I'm going to type that into my calculator, and I get -268.5 newtons, which means that Fn is also equal to positive 268.5 newtons. Okay, so that's 2 points there. Make sure you're showing all of the work required for that. For C, we're asked to find the magnitude of the force of kinetic friction acting on the box. Force of kinetic friction, the magnitude is mu k times Fn. Okay, so that would be the coefficient, which is 0.23, times Fn, which is 268.5. And most people on this test did pretty well on this question. Okay, I will tell you where we went wrong in just a second. Okay, and so here that comes out to be 61.8 newtons, and that's for C. Now, when we get to D, here's where we start having issues. When you write down your second law equation in the x direction, yes, it's accelerating in the x direction, so I have 31ax. I write down the sum of the forces. I have Fa plus Ffk plus Fgx. But when you get to plug in values, you have to be very careful with the signs. Okay, if it's being pushed down the incline, that means Fa should be negative. Okay, assuming that your coordinate system has, down the incline is the negative direction. So when I go to plug in Fa, I'm going to plug in negative 682 plus Ffk, which is up the incline. That's going to be a positive 61.8 plus Fgx, which is also down the incline. And so that's negative 268.5, and all of that is equal to 31ax. Alright, and so this is pretty simple to solve algebraically. Okay, and so let's say divide by 31, so I get negative 10.7 meters per second squared. That's 2 points there. The biggest place people made a mistake was on the signs. Okay, so I took off lots of points if you mess up on the signs. It's very important. And then for E, it says determine what the acceleration of the box would be if the box was pushed up the incline with the same applied force. Okay, and so this is the acceleration for D. For E, if we're pushing the box up the incline, that means the applied force is now a positive 682. Okay, FFK is now going down the incline, okay, which means that FFK becomes negative. So in other words, there's a sign flip. There's a sign flip on FA, and there's a sign flip on FFK. Okay, so now we have positive 682 minus 61.8, and minus Fgx, which is still down the incline. Okay, and so if I do all that and divide by 31, for E, I get AX equals a positive 11.3 meters per second squared. Okay, and so most people did fine on the step there. Some people didn't show enough work, and then some people just completely messed up on the signs. They had FA as positive, even though it says in the problem it's being pushed down the incline. Okay, so pause it there if you need to look at that some more. Okay, question 3. We did this almost exact same problem in class the day of the test as the warm-up question, so there's absolutely no reason anybody should have missed this question. Okay, so we have a two-object problem here. Okay, and so notice that Johnny Cartoon Drawing Johnson is pushing on 2 boxes, but he's only applying a force on box number 1. Okay, so let's say this is mass 1, this is mass 2. For mass 1, the FBD would look like this. We have FG1, we have FN1, we have the applied force, and then because box 1 is touching box 2 is pushing back on box 1. So we have F box right there. Okay, for the other object, the only force we have in the x direction is F box. Okay, because now if you focus on what is touching box number 2, the only thing touching box number 2 is box number 1. So that would be F box, like that. Okay, but notice that this is going in the positive x direction and this is going in the negative x direction. So when I write down my second law equations, I have F net x equals m1ax. Okay, so that would be 12ax. I write down the sum of the forces in the x direction. I have to have Fa minus F box, and this minus sign has to be there in order to correctly use the elimination process in the next step. For box 2, we do the same thing, write down Newton's second law. Okay, so we have 7ax, we write down the sum of the forces, but there's only one force in the x direction, and that is F box in the positive x direction. So here's F box equals 7ax, and this is perfectly set up to solve using elimination. I just add the two equations together. Minus F box and positive F box cancel out. If you didn't have this minus sign here, I took a point off. Okay, here the applied force is 307. On the right side, 12 plus 7 is 19. And so AX is just going to be 307 divided by 19, which is 16.2 meters per second squared. Okay, from there to find the tension, all you have to do, or not the tension, to find F box, all you have to do is take that and plug back into the equation. And again, we did a problem exactly like this right before the test, and so there's no reason that you should not have gotten full marks on this question. There was literally minutes before we took the test. Okay, so that is question number 3. Pause there if you need to look at that some more. Okay, question number 4, by far the most difficult question on here. Okay, so in the diagram below, the coefficient of kinetic friction between the 50 kilogram block and the surface of the table is 0.25. The 50 kilogram block is pulled on by 2 different ropes, each one connected to a different hanging mass via a pulley. Notice that there is 2 different ropes. That means there are 2 different tensions. That is very important. Okay, so what would the FBD look like here? Well, the mass on the right is heavier than the mass on the mass on the left. And so I have FG2, I have FT, I'm going to call this FT2, and I'm going to choose a coordinate system whereby clockwise is the positive direction. And I can infer that's going to work because, well, if the mass 2 is heavier than the mass 1, then obviously it's going to accelerate in the clockwise direction. So I'm going to make FG2 positive, FT2 is going to be negative. You had to get the signs correct to get full credit on this problem. Okay, for the 50 kilogram box, I'll just call this one mass 3. We have FG3, we have FN3, and then there's 3 forces in the x direction. There's FT2, there's FT1, and then because it's moving to the right and there's friction, there's also kinetic friction also going to the left, FFK. And then for mass 1, we have FG1, and then we have FT1. Okay, so the first question asks you to find the magnitude of the force of friction acting on the block. To do that, all you have to do is find the normal force and multiply by the coefficient of friction. The object is not accelerating in the y direction, so you just have Fn plus Fg. It's very easy to show that Fn is 500 newtons, and FFk is 0.25 times Fn, which is 125 newtons. Okay, so that's a 1-point question. That's a pretty easy question. B says, apply Newton's second law for each of the 3 objects shown above to determine a system of 3 equations and 3 unknowns. Write the 3 equations in the space below with a box around them. Okay, a lot of people couldn't follow directions on that one for some reason. Okay, so pause it here if you need to write this down. Okay, so that is 125 newtons. Keep that in mind for a second. So I'm going to write down 3 different equations, and they all come from Newton's second law. Okay, so I'm going to start with mass 2, the one on the right. Okay, so for mass 2, I have F net y equals m2ay. That is 78 in this problem, times ay. I write in the sum of the forces, and then I have Fg3 minus Ft2. The minus sign is important, okay, because all my clockwise forces are positive. Which also means, by the way, this force is positive and this one is negative. Okay, so I do the exact same thing for mass 1, and I am going to get, let's see, I don't know why I did Fg3, that should be Fg2. Sorry about that. I'm going to do the exact same thing for mass 1, and if I do that, I get Ft1 minus Fg1. Where a lot of people had issues on this question is recognizing that there's 2 different tensions. That and making silly sign mistakes is where a lot of people went wrong. Okay. Finally, I write down the second law equation for the 50 kilogram box, but this one I do in the x direction because this box is accelerating in the x direction. So I have 50ax. The sum of the forces has Ft2, which is a positive force because it's clockwise, minus Ft1, which is going counterclockwise, minus Ffk, which guess what we just found. Alright, and so here is my system of equations. Minus Ffk, and actually I know Ffk is 125, I found that before. That's equal to 50ax. Okay, if you draw a box around these 3 equations, that's another 3 points. Okay, but you had to get the signs correct to get full marks. Okay, and then we get to C. Now, solving this system is actually very easy if you look at it. Okay, we're going to do elimination. The system is set up perfectly for elimination. All we have to do is add all 3 equations to each other. Because we have Ft2, positive Ft2, and negative Ft2, those cancel. Ft1 and negative Ft1. And then Fg2 and Fg1 we can easily find. That's going to be 780. Minus Fg1, that's going to be, let's see, the mass is 31, so that's 310. Minus that 125, and then I add up the 3 masses, 78 plus 31 plus 50. That's 159ax. Okay, so 78 minus 310 minus 125 divided by 159, and I get 2.2 meters per second squared. Okay, so that gets me 2 points, and then the last 2 points are finding the 2 different tensions. And again, if you didn't know there's 2 different tensions, that costs you a lot of points. So if I want to find Ft1, I can plug into that middle equation. So Ft1 minus Fg1, which is 310, is equal to 31 times Ay, which I just found to be 2.2. So Ft1 is going to be 310 plus 31 times 2.2, which is 68.2. That's going to be 378.2 newtons. There's one tension, and then the other tension I get by plugging into another equation with Ft2, as long as I don't mess up on the math. Okay, I can use that top equation. Fg2 is, let's see, what was it, 780. So 780 minus Ft2 equals 78 times 2.2. So Ft2, if you rearrange this with basic algebra, you get 780 minus 78 times 2.2. That's a 2, by the way, which is 171.6. So Ft2, 780 minus 171.6 is 608.4 newtons. Notice, by the way, Ft2 is bigger than Ft1, which should make sense because there is a heavier mass over there. Okay, so that should make complete sense. Okay, that is it for this test. Please let me know if you have any questions. Hopefully you feel more comfortable about this section of this unit after watching this video.